discuss. So, as we said, I'm going to start by talking a little bit about Concerto itself. So, the Concerto SIEM we have today was actually born, as mentioned, as a fork of one of the first SIEM systems created in 1998, specifically called Prelude SIEM. Prelude SIEM worked using the IDMF v1 format, while Concerto, of course, has been updated to use the IDMF v2 format. This isn't the only modification that happened, as one of the main reasons of this fork was to work with more modern technologies. So, of course, we could stay current. Now, one of the main strengths of the GUI of Concerto is the possibility to monitor both physical and cyber alerts in one singular system, which we will showcase shortly. We will also, as said before, showcase two plugins that we've developed called the macro map and the micro map. Now, let's go quickly through the architecture. So, on the bottom of this image, you can see all the different ways that Concerto can receive alerts. As you can see, it's not all from one source. It can be cyber physical infrastructure or probes or even just Logstash. All of this data travels through the Kafka bus and is read by Logstash and stored inside Elasticsearch. The GUI then uses this information that we receive to populate all the various sections of the GUI specifically, using also the Postgres storage to store the configurations. Above, we can see some of these sections that we will see and discuss shortly. The macro map and micro map, of course, the alert table, the analysis section, and the archive, also called the log table, you could say. Now, let's go in a little bit of detail about this. The alert table is, in a sense, the core, because this is where all the IDMF v2 alerts are found. All of the alerts that reach the platform are displayed in this table automatically, so there's no need for the user to know complicated commands or anything like that. And then there are multiple features such as filtering, for example, all that help the user search through them and analyze them more precisely. The archive section, on the other hand, is more statistical, you could say. It shows the logs, such as Logstash, and works in a very similar manner to the alerts table, actually. Many functionalities are the same. What changes, of course, is the data that is stored. In this case, it's not in IDMF format, but the data from the log is extracted and showed in a comfortable manner to the user. Then we got the analyze section, which showcases different graphs built dynamically using the data obtained from the alerts. And finally, the admin section. Concerto is built to allow our users, especially admins, to also create more users and, of course, give them rights. So the administrative section of the platform is also handled directly inside it, which we all found very comfortable even during development. On top of all this, Concerto also includes a plugin system, which allows its users to install all different plugins, extensions, to extend the functionalities of the platform. Two such plugins are, of course, the macro map and the micro map. Speaking of which, what exactly are they and why do they exist? So one of the key objectives of Concerto and IDMF v2 especially is to collect alerts from heterogeneous sources. This was, of course, made possible by IDMF, but is enhanced, in a sense, also by these two plugins. The idea of the plugins, to put it simply, is that the macro map is meant to give a general overview, while the micro map is meant to give a more detailed overview of a specific asset. I imagine the macro map as a Google Map style UI where the user can upload these assets as to monitor. Then the map will interface with the alerts table and obtain these alerts to help the user see the situation of each specific one. The macro map, on the other hand, is what you would use when you know, for example, something's wrong in one of your assets, but you want to see specifically what is going wrong, maybe in which specific server is launching the alert. The macro map is built this way to be especially relevant to the SOC of SOC architecture. Of course, as you can imagine, having many local SIEMs and one central SIEM is very relevant, you could say, to this tool, because they all can be monitored at once. The micromap, on the other hand, is especially relevant to the monitoring of the physical world, because, for example, one of the things that we took care to include into functionalities is the possibility to monitor cameras, and also have an idea of what exactly has been found by the camera. Now, let's move on for a moment to the macro map to talk more in detail about the creation. So we've elected to use a CSV file to configure the map. What this means is that the user has to create a file using specific fields that we've selected to describe the assets specifically that they want to place on the map, and of course where they want to place them. This file is then loaded into the map, and afterwards the monitoring can be conducted again using all the features that a Google style map would have, such as, of course, zooming, navigating around, but also some custom features such as the color changing feature, meaning that when certain thresholds of alerts of a certain severity are reached, for example, the asset will change color to quickly signal to the user that something might be happening and they need to check it. The macro map is also built to work in synergy with the micro map, so there are direct connections between the two, which we will see shortly. Now I'm going to quickly show you what the CSV file might look like. It is actually very simple. It contains certain data that helps the map showcase the asset graphically, such as the town or the nationality. Some data such as latitude and longitude will help it place the asset, of course, into the map. And then other data such as name, visible, zoom are just there as configurations. In this case, for example, its purpose is to say how close or far do I have to be in zoom before I can see the name of the asset. This is very simple. It's so simple, in fact, that we have made sure that his files could easily be written even by AI. We've tested this specifically. This file that you see here was largely made using AI because, of course, the coordinates of the bases are readily available on the internet, even though they are approximate. This can, of course, help the user create the file with much more ease than if they had to just write it by hand. Now we move on to the micromap. Now, the concept of the micromap is similar, but a little different. Instead of loading a CSV file, we would load an SVG file. This SVG file, instead of being a map, would be a floor plan or a server rack, basically a blueprint. And the only real constraint, you would call it, but not really, is that the user needs to be able to add metadata to the assets created using the SVG. In our case, we've used a program called Draw.io, but as we've also tested, it is very easy to create these files even using AI again. And we've tested that AI is capable of adding metadata to the SVG as long as you are capable of instructing it on where to do it. And the end result was very positive, if I would say. And so this is another way the user can easily create it. So, as I said, the macro map is very useful to monitor not only the specific, let's say, assets inside the room, such as a computer, but also the cameras. We've you will see that too during our presentation. Now, I want to also give a small idea of the kind of draw.io backgrounds that we can have. As I said, it doesn't have to be draw.io. It can be any kind of SVG, and this is, in a sense, has a very strong feature of the map because it has versatility. I can have a floor plan like the one you see here, but it can also be a server rack. It's the user that chooses what to upload, and the map will still be able to monitor it as long as the metadata is inserted correctly. Now, I want to continue by giving you a demonstration. In this demonstration, we will have a short visit of Concerto first and foremost, and then we will showcase a use case, in this case, the Army use case, which will involve loading in some air bases in the European zone. Then we will monitor our drones approaching one of the bases, and also we'll have a small parenthesis on the micromap where we will see an intrusion followed by an attempted access on one of the systems. Now, let's start. First of all, on the top left, we can see the sections that we've discussed so far. As you can see, they're very easily to access. While on the right, we can see some counters. These counters indicate the amount of alerts and logs that have been received by the platform. Below these counters, we can see another useful tool, which is a bar that controls which alerts are shown in the tables, in this case, filtering them by date. It is also possible to automatically refresh the platform using in this bar. And we have some extra settings that control how everything is showcased. Here we have the search bars. This can be used to filter the alerts shown, of course. And here we have the actual alerts, of course, all in the IDMF v2 format. As you can see, they are very easy to read and can also be filtered automatically without needing to write anything. When you do, only the ones that respect the filter will be shown, of course. We can also utilize his little context menu to help with this feature. Finally, here we have some extra buttons on the bottom, which help with features such as exporting in selected alerts or deleting them. Here we have the archive section, which, as I said before, is very similar to the alert table. All the functionalities that exist there also exist here. As I anticipated, what changes is the type of data we show. The alerts in this case are logs. They are parsed, and the fields as are showcased here. Finally, here's the analyze section, which showcases all these graphs. As you can see, not all of them exist because the data is not on the platform yet, but as more alerts arrive, more data arrives, and so more graphs will be shown. Here now we will see another useful feature, which is still in development, which is the ability to import your own playbooks. These are sets of alerts, which can be imported all at once or step by step. We will see more of this feature shortly. Now, the next step will be taken on the macro map itself, where we will upload a use case. As I said, in this case, it's the EU Army use case. Now, we will show how the alerts are seen, and the small context menu of each alert, which is different from the one in the alerts table, and offers different functionalities, such as navigating to the micromap. We will also upload our floor plan on the map, and now everything's ready to start monitoring. So we will once again open the import section and import our playbook. Now we will upload it and start playing it step by step. The first one has been sent, so the user uses the refresh section and notices that something has changed in one of the bases. We can zoom in immediately in one click and notice a drone approaching. with some data correlated to it. Let's continue monitoring, and here we see how the drone has approached, marked of course by the dotted line. We can continue refreshing, and now the alerts are different. The map just shows that a high severity alert has arrived, so the asset has changed color. In this case, the intrusion has been confirmed. Now we go back to monitoring the general situation, and another alert has arrived on a different asset completely elsewhere in Europe. We can check around, but notice that nothing is being detected, so let's check inside. And yes, the camera has detected a person attempting something inside the building. Let's continue monitoring and can see what happens. Yes, a computer is now red. Let's see what happens by entering in the alerts table. And as we can see, someone has attempted to access the device. So the operator will now notify the guards, has to intervene immediately. And a request has been submitted, which will send a message. This marks the end of our little demonstration. As you can see, the macro map and the micro map working together help really sell the idea of monitoring physical and cyber together, as both have been involved in this case, which is actually very plausible and also very concerning, especially in today's day and age. Before I leave you, I want to do a small parenthesis on the code. As you know, all the code that we've worked with is open source. And of course, if you want to see everything that I showed you for yourself, we actually encourage you to do it. You can download everything and see it yourself. You can even try creating something for it yourself if you want. What we have is Concerto SIEM, of course, the main attraction, you could say. The macro map and the micro map, which are the plugins we've seen today. The documentation for all the useful information you might need. The validator, which is another tool we've developed. We've developed it to help users both learn IDMF and validate their own alerts. It works by comparing the message that is written inside it with the selected IDMF format. And finally, we have all of our libraries and connectors, which are, of course, all the tools that we've developed to facilitate the use of Concerto. For example, we've discussed QRadar. One of the tools we've developed and are still developing is a connector from the QRadar format to the IDMF format. Okay, this is all for me. So I will now leave the floor back to Evalda.